Welcome to my channel Maths Pursuit. Today we will look into the questions from the chapter called Polynomials. Here the given question is, what is remainder theorem? Let us discuss on this in details. Let us try to understand here about the remainder theorem. Let us try to understand here about the remainder theorem. This is one of the most important theorem that we need to understand. If we get to know this theorem easily, if we get to know this theorem well, then we can answer most of the questions, or we can answer most of the divisions that the book or that any of the questionnaire might ask us. So if you look here, let us find out what exactly is meant by remainder theorem. Now I have posted here the definition of remainder theorem and we will discuss on this right now. If you look here, what does it mean by remainder theorem? If you look here, what does it mean by remainder theorem? The remainder theorem tells us that the remainder theorem states that when a polynomial px is divided by a linear polynomial x minus a, the remainder of that division will be equivalent to pa. Just this is our remainder theorem. What is our remainder theorem? It states that the remainder theorem states that when a polynomial px is divided by a linear polynomial, this is a linear polynomial because it is having the degree of x is having only the degree of 1. So when a polynomial is divided by a linear polynomial x minus a, the remainder of that division will be equivalent to pa. So here the division, if we divide a polynomial px by a linear polynomial, the remainder will be pa. Now there is also one other clause in this. We need to also understand this one. It should be noted that the remainder theorem only works, this is most important. Remainder theorem only works when a function is divided by a linear polynomial. When you divide a polynomial by a linear polynomial only, that means by this type of x minus a or some x with some constant, then only our remainder theorem will work. Otherwise our remainder theorem will not work. So looking at to this specific clause, it should be noted that the remainder theorem only works when a function is divided by a linear polynomial, which is of the form like you could see here, x plus the given number or x minus the given number. X plus the given number or x minus the given number. Here in this case it is x minus a. Here in this case it is x minus a, or it could be x plus a. Now let us discuss about this remainder theorem in details below. So again, let me read out. The remainder theorem states that when a polynomial px is divided by a linear polynomial x minus a, the remainder of that division will be equivalent to pa. So let us try to understand this one, or let us try to derive how this exactly, let us try to prove, I can say. Let us try to prove this remainder theorem. Now let px, because we are going to divide px by x minus a. So let px be a polynomial. Let px be a polynomial. Let px be a polynomial of degree. Be a polynomial. Please try to understand this one. This is most important theorem. Be a polynomial of degree greater than or equal to 1. Degree greater than or equal to 1, or equal to 1. This is one thing. And the second thing here is, because we are discussing about if you look here to the definition, we are discussing like if px is divided by x minus a. So what is a here? A is any real number. A is any real number. This is a is any real number. So I can write a is any real number. Any real number. And then x, and then we can take qx. Let q, because we are dividing, if we are dividing px by x minus a, that means x minus a is our qx, or that x minus a is our divisor, not qx. X minus a is our divisor. So qx is our quotient. Qx, just I am taking qx as quotient. We do not know what is the quotient, just I am considering the quotient as qx. Now what we considered, we considered px be a polynomial of degree greater than or equal to 1. A is any real number. Now, and we have considered quotient as qx. Now, as per the question, or rx, let rx again be our remainder, because we do not know what is this. These are the things we do not know about these quotients and reminders. So we are just considering these things. What we considered px be a polynomial of degree greater than or equal to 1, and then we considered a be any real number. From where we got a? Because if you look into the theorem states that if px is divided by x minus a, so this a is any real number, and then we are considering let qx is equal to quotient and rx is equal to remainder. Just we are assuming these things. Now let's look this thing. After taking these assumptions, let us see. We very well know what we know. We very well know that what we know. We very well know that dividend is equal to this formula. We very well know dividend is equal to divisor into quotient plus remainder. This is the most important formula that we know. If we divide a number by another number, this is we can check our answer. This is how we can check our answer. Divisor into quotient plus remainder. Now let us put these things as per the theorem. Let us put these things. So dividend is px. When we are dividing px by another, as per the theorem, we are dividing px is divided by x minus a. So here divisor is x minus a into quotient. Quotient is qx. We have considered the quotient as qx. If you look here, we have considered the quotient as qx and remainder as rx. Just I am going to prove this theorem. So dividend is equal to divisor into quotient plus remainder. So here dividend is px, that is equal to divisor is x minus a, and quotient we have assumed quotient as qx and remainder as rx. So this is what we are getting, this type of equation or expression. Now I can write or px. Now I can write or px is equal to x minus a into qx plus r. How plus r? This is most important. Let us try to understand. Now if you look here, this is the first part. If you look here it is x minus a into qx and rx. We very well know that we very well know that the remainder should always be 0, or the remainder would either be 0 or less than the divisor. This remainder is either 0 or less than the divisor. Now let me explain you this one so that it would be more easy to understand. If we are considering some number, let's say if we are dividing 7 by 2, then we are getting 2 3s are 6, and we are getting the remainder as 1. This remainder 1 is either this remainder will be 0 or less than the divisor. Here the divisor is 2 and this remainder is less than this 2. So this is the condition for all the times. So what we are getting here, we are getting 1 which is less than this 2. That means the remainder is always either 0 or less than the divisor. Now if this is less than the divisor, how it happened? Here if you look here, our divisor is x minus a. That means our remainder will definitely, x minus a is like x to the power 1 minus a. That means our remainder is only a constant. How it is only a constant? Because r plus x to the power 0. This is only a constant because r plus x to the power 0. The degree of the remainder should always be less than the degree of the divisor. Here the degree of the divisor, highest degree of the divisor is 1. That means here the remainder's degree would be 0. Or we simply write it as r, because it cannot be more than, it cannot be equal, or it cannot be more than the divisor. The degree of this remainder, the variable of the degree of this remainder should always be less than the degree of the divisor, or it should be 0. So here, as I told you, this is r plus x to the power 0, which is nothing but r plus 0. Keeping this thing in mind, that means we are going to get only r, not rx, not this rx. We are only going to put it as r now. So our remainder now becomes r. Please try to understand this one. So now just let us consider one more thing now. What we got the remainders are here. Px is equal to x minus a into qx plus r. Now let putting x is equal to a, just we are putting or assuming x is equal to a. Now putting the value of x is equal to a, let's see what we are getting. PA, I am going to put this value of x is equal to a in this equation, like let it be equation number 2. So PA is equal to a minus a. How? Here we have, here if you look here, we have x minus a. Just replacing the value of x with a. So we are getting a minus a into qx into qx. Qx means again we are replacing it by a plus r. Hope guys I am very clear till here. So just I am replacing the value of x with a. We are assuming let x is equal to a, or I can write PA is equal to this plus a minus a, it cancels out, we are left with 0 into QA plus R, or I can write PA is equal to R. How? Because this 0 into something, 0 into anything is 0. This 0 into anything is 0. So we are left with 0 plus R, or simply I can write PA is equal to R. Hope guys you could understand this. So what we got? We got PA is equal to the remainder. That means thus it is seen that the remainder is PA when PX is divided by x minus a. How PA? Because we proved that either PA is remainder. Here we proved that PA is nothing but this is the remainder. So here we easily proved. We can write here because we concluded that okay, PA is our remainder. So we can write that thus it is seen that remainder is PA when we divide when PX is divided when PX is divided by x minus a. Hope guys you understood this. This is little bit confusing, but try to understand it minutely so that you can easily get to it. Nothing more difficult. This is nothing difficult is that. Just try to understand this. The most important concept is how this became only R. And if you can understand how it became only R, then it would be more easy, because how it became R, that as I explained to you, our remainder is always less than the divisor. Keeping that thing in mind, here we cannot keep any value, anything included with any x variable or any variable included with R, because our remainder is always less than either 0 or less than the degree of the divisor. But here the degree of the divisor is x to the power 1, so the degree of the remainder will be 0. So here only we are left with x or with R. Hope guys you understood this, but still if you have any questions, please feel free to let me know. Now what we got? We got that the remainder is PA when PX is divided by x minus a. Now keeping this thing in mind, we have certain observations. I have noted down certain observations which would be more helpful if we get any type of questions. Now let me put these observations here on this screen. Let us look here to these observations. I have just posted these observations. We will just quickly analyze these observations so that it would be easy for us to answer any type of questions or any type of reminders, any type of things that the question might give us. So we can easily answer this type of things. Now if you look here, I have just noted down 5 observations from using our remainder theorem. I have noted down 5 observations using our remainder theorem. So our remainder theorem, the first observation that we got, that when Px, this is our first observation 1, Px when Px is divided by x minus a, that is what we calculated out, then remainder is equal to Pa. How we got? Here if you look, the 0 of the divisor is like our divisor here is x minus a, so its 0 will be x minus a is equal to 0 or x is equal to a. or x is equal to a. This is what I have explained it here clearly. So here the 0 of the divisor is a. Now why we considered px, why we considered how we considered px is equal to a, by looking at the 0 of this divisor. Here we got the 0 of the divisor, x minus a is equal to 0 or x is equal to a. Then only we replace this value of the polynomial px with pa. For that reason we replaced the value of px with pa, and then we proved our theorem. So this is what we got. This is observation number 1. Now coming to the observation number 2. When px is divided by x plus a. In observation number 1 we divided px by x minus a. Here we are dividing px by x plus a. So when we divided px by x plus a, our remainder will be pa. Here our remainder will be pa. Try to look here. Here our remainder will be p minus a. Here our original remainder that we considered is pa. Here our remainder is p minus a. How we got? When we divided px by x plus a, that means x plus a. Here if you look here, x plus a is equal to 0, the 0 of the divisor. Here x plus a is equal to 0 or x is equal to minus a. Therefore the remainder is p minus a. Similarly, look at the observation number. Now look at the observation number 3. The observation number 3, when px is divided by ax minus b. When px is divided by a linear polynomial ax minus b. These are all linear polynomials, guys. These are all linear polynomials. This theorem only works with the linear polynomials. Without the linear polynomials, this theorem will not work. So when px is divided with this linear polynomial ax minus b, then the remainder that we will get is pb upon a. Pb upon a. How? The 0 of the divisor, that is ax minus b, is equal to 0, or ax is equal to b, or a is equal to b minus a. So here the remainder, when px is divided by ax minus b, we are getting the remainder as p b minus a. Similarly, when px is divided by ax plus b, then the remainder will be p minus b by a. And the other last one is when px is divided by b minus ax, then the remainder will be p b upon a, p b upon a. These are the things. These are the 5 observations that we will get. If we get any of the questions where we will get a polynomial, where a polynomial is given and we are given a linear polynomial to divide that polynomial, we can easily use these observations and we can quickly answer our questions. So in our questions, whenever I get any question, I will be using any of these observations, and I will be answering the questions. So you will see that I will be referring to these observations more often whenever we get any of the polynomial, when we divide any of the polynomial with a or by a linear polynomial. Hope guys you understood this, but still if you have any questions or doubts, please reach out to me in the comment section of this video. Definitely I will get back to you once I see your comments. Guys, if you really like my videos, please subscribe and let your friends know. If you really like my videos, I would request you to kindly subscribe and also let your friends know. This will motivate me to create similar videos in the future. Thank you. Bye.